Welcome to Sundar's lecture. This is lecture number 59, and in this lecture we are going to see Millman'S theorem. Before that, what are all the topics we have seen in the previous class? In the previous class we have taken reciprocity theorem. Right? So in reciprocity theorem we have applied intelligence theorem to prove the reciprocity theorem, and then we have taken a problem to solve using reciprocity theorem. Now you try to understand one thing in this proof. We have taken two circuits, right? This is circuit number 1 and this is circuit number 2, and you see the current directions in both circuits are same. I1 is like this and I1 dash is also like this. I2 is like this. I2 dash is also like this. So, and then with this we have derived, this is the expression for finding out what is the current in the second network, right? That is what we have seen, right? But here you see this is I1, but I1 dash is in opposite direction, and see this is I2 and I2 dash is in opposite direction, right? So there must be a question why we should take opposite direction current, but the formula we have used is the same. Try to understand. You have changed I1 to I1 dash in the opposite direction, so put minus of I1 dash here, and also I2's current direction also changed. So also you put minus in this expression. So minus and minus will get cancelled each other. So anyhow, if you put the voltage source to the other side, then obviously your current direction will change. Both current directions will change. So it is not necessary to show that it is minus here, it is minus here, and so we are getting these kind of expressions. Try to understand these things. So in this class we are going to see Millman'S theorem. See, this is the network. For example, there are n number of branches with a voltage source series with an impedance is connected like this parallelly, right? So how we can do this? We can convert this whole network to a single voltage source and a single impedance connected series across point A and B. And the expression for Vm and Zm will be the proof for Millman'S theorem. That is what we are going to find now. And what is Vm and what is Zm? For example, what we can do, we can just using source transformation. By using source transformation, see, we have just applied source transformation to this circuit and we have converted the voltage source to current source. And if you convert voltage source to current source, and the impedance should be connected parallel to the current source. And what is this value of current? What is the value of current? You know what is I? I will write it down here. I1 should be is equal to V1 divided by Z1, right? We know that. This I1 and also I2 should be is equal to V2 divided by Z2, and also up to In should be is equal to Vn divided by Zn. We know these kind of things, right? And what is Z1? Z1 or else you see Z1 can be written as 1 by Y1. What is Y1? What is Y1? Y1, which is nothing but it is the admittance value. Maybe I can write it like this. Anyway, why? You see, I will explain you why I am writing like this. Then Z2 can be written as 1 by Y2, and then Zn can be written as 1 by Yn, right? We can write like this. So this is the value. So now you see, if current sources are connected in parallel, then what is the total current? If I want to convert this to a single circuit, since you see, I'm just going to do like this to a single circuit, right? Like this. If I am doing this one, across point A and point B, I need to convert this circuit to a single current source, and that I am just considering it to be Im, and a single impedance, I am just considering it to be a different name, maybe Zn, not Zn, maybe Zs, because I am just using Zm here. So what is this one? What is Im now? So Im should be what? Im if current sources are connected in parallel, then obviously all the current sources can be added. If voltage sources are connected in parallel, then all the voltage sources can be added. Since all the current directions are same, so I can write this is I1 plus I2 and plus it will be going on to IN. How many number of current sources are connected? And if I want to find what is ZS, then ZS can be written as, if it is connected in parallel, then what I can do, see, I will just write it down as 1 by ZS. Since it is connected in parallel, that should be is equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3. I can write like this, or I can write ZS should be is equal to, I'm just inversing this. So this should be is equal to, what is 1 by Z1? 1 by Z1, this one will be Y1, right? You just go this one, you just bring this one to left hand side and Z to this one. So it will be 1 by Z1 will be is equal to Y1. I can write it as Y1 plus Y2 plus it will be going on to Yn. Here also, right? I have just made a mistake here. So it will be plus going on to 1 by Zn. So this is how you can write down the expressions, right? Now you see this is Im and this is Zs, and this parallel circuit can be converted into a voltage source connected in series with the resistance or impedance. See how I can draw this one. This one also can be converted like this, right? So I am just drawing this like this. See, I have just drawn across point A and point B. Again, I am just converting the voltage source to current source to voltage source, and this I am considering it to be Vm, and this I am considering it to be Zm. This is plus minus. And what is Vm now? What is Vm? Obviously, you can write Vm should be is equal to current into impedance value, that is Im into Zs. Just I can write like this, right? So what is Im here? This is Im, right? This is Im. What is I1? What is I1? I1 we know this is V1 by Z1. So what I can write it down? V1 by Z1 plus V2 by Z2. Maybe I will write it down here in a new space. So I will write down here. So Vm should be is equal to V1 by Z1 plus V2 by Z2 plus it will be going on to Vn by Zn whole divided by, sorry, yes, I can write it down into Zs is 1 divided by this one, right? So it will be 1 divided by Zs. I am just writing it as Zs, then I will convert this one. So finally I can write Vm is equal to, right? Vm is equal to summation k is equal to 1 to n. I am just generalizing the term V k, and I am just writing this 1 by z as y. 1 by z as y. So yk up to n it will come, right? This is divided by, what is this one? This one will be 1 by Zs will be is equal to what? Y1 plus Y2 plus Y3 plus Y, it will be going on, right? So it will be going on, which means what I can do? Summation k is equal to 1, it is yk. It is yk. What I can write it down? So y should be is equal to, what is the value of y? So this is the 1 by z1, 1 by z1 plus 1 by z2 plus 1 by Zn, right? It will be going on, and this value, it is nothing but this one. So Vm can be written as like this. This is the value. And what is this Zs now? This value, Zs, which is nothing but this value. So Zm, I am just writing it as, which is nothing but it is Zs. So it will be 1 by summation k is equal to 1, which is nothing but it is yk. That's all. That's all. We have found both the values. right? This is Vzm and this value is Zm and this value which is nothing but Vm. Can you understand? Can you understand? And what is y? You should understood that y which is nothing but it is 1 by z1, and I will write here y which is nothing but it is 1 by z, whatever it may be, y1 or y2 or y3, whatever it may be, right? So this is how you have to convert these values. You can find Vm and Zm. This is nothing but Millman'S theorem, right? So let us take an example, numerical example with the AC circuit, and we try to find what is the current in a particular resistor, right? That I will do now. See, this is the problem given. So find current through 2 ohms resistor by Millman'S theorem. Just they have given you like this. See, for example, if they are giving you a problem like this, then what you do, you need to find what is the current in 2 ohms resistor. Then you redraw the circuit. How will you redraw this circuit? See, I can just to understand, I will redraw this circuit now. See, I have redrawn this circuit like this. Why? Because I want to find what is current through 2 ohms resistance. So I bring it to point A and point B, and these two are connected in parallel, right? So I have drawn like this. Now you see these two can be converted, right? Because this is like this one, like Millman'S theorem. Using Millman'S theorem, what I can do, I can just convert these two branches to a single branch, So for that, what we can do, we need to find both values, these Vm and Zm, right? So I will just copy down this and then put it in the next page. So you see, so this is the Vm formula, right? So this is the Vm formula, and Vm can be written as V1 Y1 plus V2 Y2 divided by Y1 plus Y2. That is what we have done here, right? That is what we have taken here. This formula that I have just converted here. So this is Vm. And what is Zm? What is Zm? Zm should be is equal to 1 by y1 plus y2. That's all. That is what we Zm. And you can just replace these two branches with a single Zm and Vm. Right? That is the idea, whole idea. So you try to find, you see V1 is this one, V2 is this one, and you need to find what is y1 and y2. That is your ultimate aim, right? So what is y1? Y1 should be is equal to 1 by Z1. And what is Z1? 1. See, this is Z1 and this is Z2. That's all. So what is Z1 will be 3 plus 4j. And if you simplify this, you will get, so you will get 0.2 at an angle of minus 53.13 degree. And if you want to go for y2, y2 should be is equal to 1 by Z2. And which is Z2? This is Z2. So you just write it down anyhow. This is V1, this is Z1, this is V2, this is Z2. So just try to understand. So it will be 1 by 5. And if you simplify this, so it will be 0.2 at an angle of 0 degree ohms, right? This is also ohms. So we have found what is y1 and y2. Now you can substitute in this expression. So you substitute Vm should be is equal to what is V1? It is 10 at an angle of 0 degree. 10 at an angle of 0 degree into what is y1, it is 0.2 at an angle of minus 53.13 degree plus it is v2, what is v2, it is 25 at an angle of 90 degree, into, and what is y2, it is 0.2, that's all, right? You don't need to put at an angle of 0 degree. Whole divided by, this is whole divided by, and what is now y1, what is y1? It is 0.2 at an angle of minus 53.13 degree plus y2, it is 0.2. And if you simplify this whole thing, you will get, so you will get Vm is equal to 10.06 at an angle of 97.12 degree volts, right? You just calculate this using calculator, you will get this value. And next thing, you need to find what is the Zm value. And what is Zm? Zm can be easily found, right? Zm should be is equal to 1 divided by this volt, 0.2 at an angle of 53.13 degree, that is minus, here it is minus, plus 0.2. And if you simplify this, so Zm will be is equal to 2.8 at an angle of 26.56 degree ohms, right? Now you see, this whole circuit across A and B can be converted into a single voltage source connected with the impedance in series, right? So that is what we have done. That is the Millman'S theorem, right? See, this whole network can be converted into a single voltage series with an impedance. So it is nothing but we have connected like this. Now you see, you need to find what is the current through 2 ohms resistor. So what is the formula now? So I through 2 ohms can be written as, there is only one voltage source, that is Vm, divided by Zm plus 2, that's all. You can just substitute now these expressions Vm and Zm in this one. So what you will get? So Vm, which is nothing but it is 10.06 at an angle of 97.12 degree divided by, whole divided by, and what is Zm? Zm is 2.8 at an angle of 26.56 degree plus, and this is 2 ohms. That's all. This is nothing but I through 2 ohms now. So if you simplify this, so you will get I through 2 ohms is equal to 2.15 at an angle of 81.63 degree amperes. So now we have found what is the current in 2 ohms resistor. So this is how you need to proceed a problem with Millman's theorem. Try to understand Millman's theorem can be applied only in these kind of questions or these kind of problems where a voltage source and the impedance connected in series and stack of voltage source and impedance connected in series can be connected in parallel like this in this format. And if they are asking you to find what is the current across this branch, and you can easily find what is the current by using Millman's theorem. So you don't need to consider this as a node and you find what is V1 here and V1 divided by this resistance will give you current, or loop current method you have to consider this is I1 I2 and find what is I1 I2 and this will be I1 minus I2, and so many procedures are available and we have seen all those procedures in our previous lectures. Anyhow, Millman's theorem can be applied to these kind of problems. And it will be very simple, right? Just we found what is y1 and y2 and just we have substituted in these expressions, in these two expressions, we have got what is Zm and Vm, and we have just applied again a single loop problem. Like a single loop, you can easily find what is the current through this resistor. So this is how you need to apply Millman's theorem, right? So we will take another one lecture in theorems because we have seen DC problems, DC circuit problems, or we have also seen dependent sources problems for superposition theorem and Norton's theorem and Thevenin's theorem. We have not taken an AC problem, AC circuit problem. So we try to take AC circuits problems for superposition theorem, Norton's theorem and Thevenin's theorem in the next class, and then we wind up these theorems. Maybe we will take another example. Yes, we have found we have already taken AC circuit problem for maximum power transfer theorem. So for these three theorems, Norton's theorem, Thevenin's theorem, and superposition theorem, we will take an AC example, AC circuit example in the next class, and then we will wind up these theorems, and then we will go to a very interesting topic about transients in electric circuits. Right? That we will see in the maybe 61st lecture from that. Okay, right. You go through these topics, then you solve many more problems in each theorems. You will get good ideas, and if you have any doubts, please post it in the comments and I will reply for your questions. Thank you.